Are you 10s? Okay, just really quickly wanted to go through that worksheet thing. There's a couple here, sine 360, 270, and of course they're not on our exact value triangles. So how do we do those? Remember, sine theta is the vertical height when you get one of these angles. So if you had that angle there, sine theta is the vertical height. And cos theta is a horizontal distance. Remember that, everyone? Great. Okay, so how do we do these? How do we fill this table in? Sine of 360. 360 degrees all the way around is back here at 0, or 360. Remember, that's 90 degrees, that's 180, and that's 270 degrees. So sine is the vertical height, and at 360 our point is there. So there's our angle. What is the height at this point? The height is 0. So that value there is 0, because there's no vertical height at this point. When we go sine 270, okay, so all the way down here, sine 270 is there. What is the vertical height at that point there? And since this is a unit circle, it's 1, but it's negative 1, because it goes down 1. So that value there is negative 1. Same with sine 180. So if 180 is here, sine 180 goes there. The vertical height again is 0, and sine 90 is up there. The vertical height is 1, so it's positive 1. Is that okay, everyone? Excellent. Now cos is a horizontal distance. So at 360, cos, the horizontal distance is positive 1. Cos 270, the horizontal distance here is 0. Cos 180, the horizontal distance is negative 1. And cos 90, the horizontal distance is 0. Okay, so that's how you get those values. And the last one I'll do really quickly is tan. Tan is equal to, tan theta is equal to sine theta over cos theta. So now that we've got sine and cos, tan theta here is 0 over 1. 0, how many ones? If I've got $0, how many times can I give you $1? It's 0. So 0, how many ones is 0. And let's do this one here as well. 0 divided by negative 1 is 0. Alright, now this one's a bit tricky. Minus 1 divided by 0. If you're dividing by 0, how many times can you give $0 out? Infinity. So the answer is undefined or infinity. I'll accept either answer. And over here the same thing, 1 divided by 0 again is undefined. You got that, everyone? So you have to make sure you can fill in that table that I gave you last lesson. Alright, so now we'll keep on going over here. We'll start with our next topic. So, graphs of trigonometric functions. First graph we're going to look at is sine theta. So remember our unit circle. Sine value is the vertical height. So again, sine at 0. What's the vertical height at 0? It is 0. So let's put that on our graph there. And what we'll do is we'll put the amplitude. The amplitude is how high this graph is. And we know the highest it can be is 1, and the lowest it can be is negative 1. Okay, let's work out what is sine. What's the vertical distance at sine 90? We know it's 1. So at sine 90 degrees, we know our point is 1. So our point's right there. Can everyone see that? Sine 90, our value is 1. Let's go around to sine 180. Sine 180, the vertical height is 0. So sine 180, our point is 0 on the graph. Does that make sense where I'm getting those points from? Sine 270. So if the angle's there, the sine value, the vertical height is negative 1. So sine 270, our point's there at negative 1. Can you see that across there? It's right on negative 1. And there's our highest amplitude at 1. And then sine 360, which is again back at 0. And the sine value is the vertical height, which is 0. So we're back there. Okay, so now you can see on this graph, we've got a few points. They're the main points that are right on either a value 0, 1 or negative 1. So we can connect those up. Now we don't connect them up with straight lines, we need to do a curvy line. So, and it's like a wave. So it's actually called a sine wave. And in science you'll learn about this as well. So that's what our sine graph looks like. So for now, that's how we derive it. We got it from the unit circle. You put those points in and you make a nice curvy graph. Everyone do that? Alright? Okay. Let's do the same thing with the cos graph this time. Remember, cos is the horizontal distance across. So, at 0, the horizontal distance is 1. So, let's straight away put our amplitude in. Talk about that in a minute. So, there's 1 and there's negative 1. So, cos 0 is equal to 1. So, we put our point there. Notice it doesn't start at 0 like the sine graph. Okay, cos 90. There's no sideways movement, so it's 0 at 90. 180, it's negative 1, so we put it down at negative 1. 270 is 0 again, so we put it there. And 360 is back to 0, and it's equal to 1 again. So we put our value back up there. Now you can see we've got a cos graph that looks like that. And again, we don't use straight lines, we do it nice and curvy. So it looks something like that. And both of these graphs, they continue on forever. So like I said before, if you make this, I'll talk about this now, the amplitude is the maximum height of the graph. So the amplitude is 1, goes up to 1 and down to negative 1. And the period of the graph is the time it takes to complete one full cycle. So if we just go back to this one, starts off at 0, goes up, down and back to the start again, and the period of that is 360 degrees, which is the same as 2 pi radians. So that's one complete period of the graph, and it's the same over here. So we start down there, end back up there, and it's 360 degrees. So if we chop it off there, that's one complete period of the graph, and it goes on forever. So if you spin around this unit circle twice, it gets 720. So you'll have the same value as 360. Excellent. So that's the first two graphs. I'll do some questions in a couple of minutes. Alright, let's do some questions. How are we going to solve these questions? So, for the graph y equals sine theta, which is here, find the values of theta when sine theta is a half. So this whole graph thing is equal to a half. So where is that equal to a half? We find here. Here it's 0, here it's 1. So a half is about there. So what we need to do is go across to our graph and then move down. And that value, it should, haven't done it very accurately, but it's actually 45 degrees. So the first answer is theta equals 45 degrees. The more accurately you draw the graph, the better your result will be, of course. But the problem is we can find another solution. So we go across and we hit this point here, we go down again, and it's actually the same, these are symmetrical graphs. So if that's 45, halfway between there, is actually halfway there. So 90 plus 45 is 135. Whoops, so that's equal to, so theta is equal to 45 degrees and also 135 degrees. Because there's two solutions within that period of 0 to 360 degrees. If you continue this graph on, then you get more solutions indefinitely, depending on how long your graph was. Great, let's do one more. Over here we've got a cos graph. So make sure you copy these down as well, everyone. So the first one's got two parts. Estimate the value of cos theta when theta is 200 degrees. So this time we have to find where theta is 200 degrees. So 200 degrees is around about there. So we go down to our graph and then across to here. And of course, the more accurate you are, the better your answer. And the answer is negative 0.9. You see that? You go down, hit the graph, and go across and read off the value. So the value of cos theta here, say, so cos theta is equal to negative 0.9. Alrighty, and the last one. Find two values, or sorry, it says estimate the two values of theta when cos theta is 0.7. Alright, so cos theta 0.7 is around about there somewhere. So we move across and go down, and my estimation is the first answer is 45 degrees. So theta is 45 degrees, but we have to keep on going across until you get to this point here, go down, and since it's symmetrical again, so 270 plus 45 is 315 degrees. So theta is 315 degrees. That's how you do that. Both these answers can be checked on the unit circle. So if you had cos 315 degrees, you can do like we've done in previous lessons, find the reference angle, and you should find 45 degrees. So you can check your answers. You can also use CAS to check your answer. Anyway, that's it for now. So now we've got 4K, 1 to 6 every second question. Now we've finished the whole topic. You can also do questions from the chapter review. I've got an online practice test for you from Cambridge, and I'll also get you a written one as well. So awesome, have fun kids, smash that like button.